In this video, we're going to learn about rotations on the coordinate plane. A rotation is a transformation which turns the figure about a fixed point. Okay, this fixed point is called the center of rotation. All right, and for our purposes in this class, the center of rotation will always be the origin. You'll be seeing different centers of rotation in a high school geometry class. The original object and its rotated image will have the same shape and the same size. They will face in different directions, however. Okay, and the orientation of the two will be preserved. The orientation is preserved, meaning that the order of the letters is the same. Now, since a rotation creates an image that has the same shape and the same size as its pre-image, that means that the figure is congruent with the original figure. Okay, when we take something and we rotate it, the image is going to be congruent with the original figure, meaning that a rotation is an example of a rigid motion. Rigid motions always create images that are congruent to their pre-images. We've seen other rigid motions, including translations and reflections. When we turn or rotate our objects, we can do that two different ways. We can either do a clockwise rotation or we can do a counterclockwise rotation. Okay, a clockwise rotation, it's called clockwise because it would move in the same direction as the hands on a clock would. So something like that, okay? It would move in this direction. All right, and for our purposes, a clockwise rotation will always have a negative degree associated to it. Okay, so if they want you to rotate something negative 90 degrees, that means it's going to rotate clockwise. All right, for our purposes, a clockwise rotation or counterclockwise rotation, which is going to go in the opposite direction as the hands on the clock, so in this direction, that will have a positive degree. Okay, so anytime they want you to rotate by a positive number of degrees, that shape is going to be moving counterclockwise. Okay, and as an example, okay, I've got my letter T here. If I wanted to rotate it 90 degrees clockwise, well, 90 degrees clockwise is going to take me in this direction right here, 90 degrees. And so here I would have the image of the letter T, and it would look something like this. Right? If I wanted to rotate this letter T 180 degrees, okay, well, again, I'm going to be moving counterclockwise, so it's going to be moving in this direction. Okay, and 180 degrees would take me over here, and my image would look something like this. It would compared to the original T that I started with. If I wanted to rotate 270 degrees, again, that's going to be counterclockwise. That would be 91, 80 to 70 would take me over here, and my image of the letter T would look something like that. Okay, that would be a 270 degree rotation counterclockwise. Okay, and then this one right here again was a 180 degree counterclockwise rotation. Now I could get from this original letter T to this image of the letter T by moving clockwise in this direction. Okay, but that would be by a negative 90 degrees. Okay, again, moving clockwise would be a negative degree rotation. So to go from this letter T to this letter T, that's a negative 90 degree rotation. If I went from this letter T in this direction to this letter T, that would be a negative 180 degree rotation. Counterclockwise rotations are positive degrees, while clockwise rotations are negative degrees. Okay, and the same thing could be said here for your letter H. You could move 90 degrees clockwise to get an image that looks like that. That's 90 degrees. You could rotate it 80 degrees, and then you get an image that looks like this. Okay, or you could rotate it 270 degrees, 270 degrees, and then you would get an image that looks like this. And again, to go from here to here, that would be a negative 90 degree rotation. Now that we understand a clockwise versus a counterclockwise rotation, we're ready to look at some examples on the coordinate plane. All right, and in our first example, we have triangle ABC, which has been graphed right here on the coordinate plane. All right, and looking at that, it's primarily here in quadrant number 1, except for point C is actually on the x-axis. Let's go ahead and give the coordinates of triangle ABC. All right, point A is located at 1, 4, so 1 unit to the right of the origin and then up 4. Point B is located at 5, 2, so 5 units to the right of the origin and then up 2. And then point C is located at 2, 0, 2 units to the right of the origin right there on the x-axis. What we're first going to do is rotate triangle ABC 90 degrees, and again, that would be a counterclockwise rotation because this is a positive degree. We're going to label our triangle as A prime, B prime, C prime. All right. And the easiest way for us to go ahead and figure out where that triangle is going to be located is to actually take our paper and rotate it counterclockwise 90 degrees. All right. And so that's what I'm going to do here with this picture. Okay. I'm going to rotate my paper counterclockwise. All right. And that is a 90 degree counterclockwise rotation. Okay, and what I'm going to do now is just use this as my y-axis and then use this as my x-axis. Okay, so what we're going to have here, we're going to figure out what the coordinates of our point are going to be. Okay, so if you notice right here, point A, all right, is 4 units to the left and up 1. So for our A prime, we're also going to go 4 units to the left and up 1. So if I rotate back to the normal picture here, 4 units to the right, 1, 2, 3, 4, and up 1. This point right here is going to be A prime. Okay, so that's where A prime is located. Now let's do the same thing for point B. Okay, so point B now is 2 units to the left and then up 1, 2, 3, 4, 5. So 2 units to the left and up 5. Let's put our picture back. All right, and let's go now 2 units to the left and up 5. 1, 2, 3, 4, 5. Right there is going to be B prime. And now we need C prime. Okay, so rotate clockwise, counterclockwise rather, 90 degrees. C is now 2 units up from the origin. So going back to our original picture, go 2 units up, 1, 2. Right here is where C prime would be located. Okay, so now I can give the coordinates of my new triangle A prime, B prime, C prime. All right, A prime is located at negative 4, 1. B prime is located at negative 2, 5. And C prime is located at 0, 2. All right, go ahead and take a ruler or a straight edge and connect those points on your graph. So I've just used my ruler and I've connected A prime, B prime, and C prime. So this is the image of triangle ABC following a 90-degree rotation, which again takes it counterclockwise. So it's moving in this direction. So A moved to A prime here, B moved to B prime here, and C moved to C prime here. What we're going to do next, okay, we're going to rotate triangle ABC, which is our original triangle right here, 180 degrees counterclockwise, and this will be labeled as A double prime, B double prime, C double prime. And so again, the easiest way to do this is to actually just rotate my paper 180 degrees, and I'm going to do that in the counterclockwise direction. Okay, so going in this direction counterclockwise. That's 90 degrees. And now I need to go 90 more degrees right here. Okay, and now this is how my paper is oriented. So again, this is going to be my y-axis. This is going to be my x-axis. And I'm just going to record what the location of the points are. So point A is down here now from the origin. So I would go 1 to the left and down 4. 1 to the left and down 4. So if I put my paper back to the normal way, let's go ahead and do that. 1 to the left and down 4. Right here is where point A double prime is going to be. A double prime. Okay, let's do that again for point B. Okay, point B is located right here. So from the origin, 1, 2, 3, 4, 5 left, down 2. 5 left, down 2. Put our paper back. Okay, and now let's go 1, 2, 3, 4, 5 to the left and down 2. That is where point B double prime is. And now we need to do the same thing for point C. So rotate 90, rotate 180. All right, point C is found right here, 2 units to the left of the origin. So I just need to go 2 units to the left when I put my paper back the normal way. 2 units to the left right here is where C double prime is going to be located. So let's go ahead and give those coordinates now. A double prime is down here, -1, -4. B double prime is right here, -5, -2. And C double prime is right here at -2, 0. All right, and again, go ahead and use your ruler, connect A double prime, B double prime, C double prime. All right, so I've taken my original triangle ABC, I rotated it 90 degrees to get to A prime, B prime, C prime, and then I took my original triangle and I rotated it 180 degrees to get to A double prime, B double prime, C double prime. I'm now ready to do one more rotation. This time I'm going to take my triangle ABC, this original triangle here, and I'm going to rotate it 270 degrees, which again will be a counterclockwise rotation. So it's going to move in this direction, 270 degrees. This will be A triple prime, B triple prime, C triple prime. So what I'm going to do, again, I'm just going to rotate my paper 270 degrees counterclockwise. So this would be 90, 180, 270 degrees. And now I'm just going to see what happens to where A, B, and C are located. So here's point A, and that is 4 units to the right and down 1 from the origin. 4 to the right, down 1. So if I put my paper back the normal way, if I go 4 to the right and down 1, right here is where A triple prime will be located. Okay, do the same thing now for point B, 90, 180, 270 counterclockwise. Point B is located right down here. So from the origin, I'm going 2 to the right, and then I'm going down 5. 2 to the right, down 5. So let's put our paper back to normal. 2 to the right and down 1, 2, 3, 4, 5. Right here is where point B triple prime is going to be. And now one more for point C. So again, rotate your paper counterclockwise, 90, 180, 270. Point C is 2 units down from the origin. So if I put my paper back the normal way, 2 units down right here, this is where point C triple prime will be located. Okay, so let's give those coordinates. A triple prime is right here at 4, -1. B triple prime is right down here at 2, -5. And then C triple prime is right here at 0, -2. All right, go ahead and use your ruler and create the final triangle, A triple prime, B triple prime, C triple prime. All right, so we've taken our original triangle ABC and we've rotated it 90 degrees, 180 degrees, 270 degrees. And what we're going to do now is investigate what happens to the coordinates under each of those different rotations. So I have a chart, and I'm going to organize my data and see if I can determine what happens under each of these different types of rotations. The original triangle ABC was at 1, 4, 5, 2, and 2, 0 for points A, B, and C respectively. For their reflection, or excuse me, their rotation image points, let's see what happened under a 90-degree rotation, which again is counterclockwise. A triple prime, B triple prime, or A prime, C, B prime, C prime were those points under a 90-degree rotation. And A was located at -4, 1. B was located at -2, 5. And C was located at 0, 2. What happened to the points of A, B, C when we rotated them 90 degrees? Well, if you compare the points carefully, notice it looks like the X and the Y coordinates reversed each other, but then the Y coordinate became its opposite. Okay, so 1, 4 went to -4, 1. I reversed X and Y, and I made this Y value from here negative. 5, 2 went to -2, 5. Again, I swapped X and Y, but I made the Y value negative. -2, 5, 0, 2, or 2, 0 rather, went to 0, 2. I swapped the X and the Y, and well, the opposite of 0 is still 0, so we get to 0, 2. So a 90-degree rotation about the origin takes the point XY, it reverses where X and Y are located, and it makes the Y value here its opposite. Okay, the negative there doesn't mean that the number is necessarily negative, it just means the opposite. So xy goes to the point -yx. A 180-degree rotation took us to A double prime, B double prime, C double prime. A double prime was located at -1, -4, and B double prime was at -5, -2, and C double prime was at -2, 0. All right, well, what happened to ABC when we rotated it 180 degrees? Look at the coordinates. 1, 4 went to -1, -4. 5, 2 went to -5, -2. 2, 0 went to -2, 0. Okay, this time XY went to -x, -y. All I did for a 180-degree rotation is take the opposite of the coordinates. The opposite of 1 is -1, the opposite of 4 is -4. The opposite of 2 is -2, the opposite of 0 is 0. XY went to -x, -y. For a 270-degree rotation, that got us to the triple primes, A triple prime, B triple prime, and C triple prime. All right, the coordinates of A triple prime were at 4, -1, and B triple prime was 2, -5, and C triple prime was at 0, -2. What happened this time? Okay, well, again, compare the coordinates. And again, looking at A's coordinates and A triple prime's coordinates, it looks like I reversed where X and Y were located, and this time I made the X coordinate its opposite. 1 became a -1. 5, 2 went to 2, -5. I switched where X and Y were located, and I made the X coordinate its opposite here. So XY is actually going to go to the coordinate of Y, -x. I'm going to switch where X and Y are, and I'm going to take the opposite of the X value. So XY goes to Y -x under a 270-degree rotation. And if you rotate something 360 degrees, you go right back to where you started. So we'd end up at the ABC again, which was 1, 4, 5, 2, and 2, 0. A 360-degree rotation takes XY and gets you right back to where X and Y were located. So these are the good rotation rules that we can learn for our coordinates to help us with a rotation. 90-degree rotated about the origin, XY goes to -YX. 180 degrees about the origin, XY goes to -X, -Y. 270 degrees about the origin, XY goes to Y -X. And then 360 degrees gets you right back to where you started. So now that we are familiar with how a point changes under a 90, 100, and 270 degree rotation, let's see if we can apply these rules to see where points will end up under certain rotations. All right. Number 4, what are the coordinates of 3, -2 under a 90 degree, which is counterclockwise rotation about the origin? Well, your 90 degree rule is right here. The point xy goes to the point -y, comma, x. And so if our original point is 3, -2, let's just follow that rule. All right. 3, -2, I'm going to take the opposite of the y, so the opposite of -2, which is 2, and then I'm going to keep the x, which is 3. So 3, -2 would map to 2, comma, 3 under a 90 degree counterclockwise rotation. All right, what are the coordinates of -5, 4 under a 180 degree counterclockwise rotation about the origin? Well, the 180 degree rule is found right here. xy maps to the point -x, -y. And again, negative in this case means opposite, not necessarily that the number will be negative. Okay, so if our original point was -5, 4, we're going to map it and use the opposite of the x and the y. The opposite of -5 is 5. And the opposite of 4 is -4. So -5, 4, 180 degree counterclockwise rotation maps to 5, -4. Number 6, what are the coordinates of 3, 2 under a 90 degree clockwise rotation? Okay, well, 90 degree clockwise is the same as 270 degrees counterclockwise. And that's this rule right here. All right, xy maps to y, -x. So xy maps to y, -x. Okay, again, negative meaning the opposite here. So applying that to the point 3, 2, first I need the y coordinate, which is 2, and then I need the opposite of x. The opposite of 3 is -3. So 3, 2 under a 270 degree rotation or 90 degree clockwise rotation would map to the point 2, -3. In example 7, it says to draw the final image created by rotating triangle RST 90 degrees counterclockwise about the origin and then reflecting the image in the x-axis. Okay, so here is our original triangle RST. We're first going to reflect it, or rotate it rather, 90 degrees, and then we're going to reflect it in the x-axis. So we need to know what our rules are. Okay, so capital R for rotation of 90 degrees. All right, a 90 degree rotation, which is counterclockwise, takes the point xy and it maps it to the point -y, comma, x. All right, and then after that, we're going to be doing a reflection in the x-axis, and reflecting in the x-axis takes a point xy and maps it to the point x, -y. And again, negative meaning the opposite in each of these cases. It doesn't necessarily mean that our numbers are going to be negative. So let's take our original points, R, S, and T, and perform both of these rigid motions here. So if we start with point R, right, point R is located right here, which is at the point -4, 4. And under a 90 degree rotation, it's going to go to -yx. So I need the negative of y, which is going to be -4. And then I keep x, which was -4. So that would be -4, -4. But then I'm going to take this point and I'm going to reflect it over the x-axis. All right, so now this point is going to go to x, -y. So the x is going to stay the same, -4. But the opposite of y, the opposite of -4, is going to be 4. And this is going to be the point R prime. So R prime is going to be at -4, 4, which is exactly where point R was located. R and R prime share the same coordinate. Let's do point S now. Point S is found right here, which is at -2, 3. Let's rotate it 90 degrees. So I need the opposite of y, which is -3. Keep the x, which was -2. So that gets us to -3, -2. and now reflected over the x-axis. So I keep x the same, -3, and I do the opposite of y. The opposite of -2 is 2, and this is going to be s prime, -3, comma 2, -3, comma 2, right here. So notice that s and s prime aren't in the same location, okay? R and R prime did land in the same location, but s and s prime did not. So this is the point s prime. Okay, and now I need point T. Point T is found right here at -3, comma 1. All right, so let's rotate 90 degrees first. I need the opposite of y. The opposite of 1 is -1. Keep x, which is -3, and now reflect it over the x-axis. So x stays the same, -1, but y becomes its opposite. The opposite of -3 is 3. And that's point T prime at -1, comma 3. 1, 2, 3. Right here is point T prime. Okay, so if we can use a ruler now and connect all of those, R stayed the same, so R and R prime are the same. So there's R prime to S prime. And now I'll connect S prime and T prime. And then the last one I will do is T prime and R prime, which gives me that picture right there. Okay, so looking at my picture here, this is my new triangle after we reflected or we rotated the original 190 degrees and then reflected over the x-axis. Now, what if we do this in a different order? Are we going to get the same picture? We're going to take this triangle, RST, we're going to reflect it over the x-axis first, then we'll rotate 90 degrees. So a reflection in the x-axis, again, takes xy and maps it onto x negative y. And then a rotation of 90 degrees counterclockwise is going to take xy and map it onto the point -y, comma, x. Let's see what happens with our coordinates. So r, which again was at -4, 4, is going to map to -4, -4 when we reflect over the x-axis. And then this point is going to rotate 90 degrees. So I need the opposite of y, which is opposite of -4 is 4. Keep x the same, -4. This is where r prime is at 4, -4. 4, -4. Down here is where r prime is going to be located. Point S was at -2, 3, reflected in the x-axis. X stays the same, y becomes the opposite. Rotate it 90 degrees. Y becomes the opposite. X stays the same. 3, -2 is where S prime is going to be. So 3, -2 right here. This is where S prime is located. And then point T was at -3, 1, reflected in the x-axis. X stays the same, y becomes the opposite. Rotate it 90 degrees. The opposite of y is 1. Keep x the same, -3. 1, -3 is where T prime is going to be. And so now I can connect those 3 points, and that will give me the following triangle. All right, 1, 2, 3, and 1, 2, 3. There we go. All right, so this is the image if we reflect over the x-axis first and then rotate 90 degrees. Are the images in part A and part B the same? Well, again, here was where r prime, s prime, t prime was located, but down here, this is where r prime, s prime, t prime are located. Are the images the same? No. The final images are not the same. The final images are not the same. Okay, the images are congruent to each other. The images are congruent, but are in different locations. Okay, so rotating and then reflecting is not going to give you the same location as reflecting and then rotating. You will get two images that are congruent to each other, but they are not going to be located in the same place on your coordinate plane. So just keep that in mind as you're working through your rotations and your reflections.